According to the National Electrical Code, also known as the NEC, an equipment grounding conductor, also known as an EGC, is not required with electrical metallic tubing, also known as EMT, when it is used as the raceway for a service entrance. The EMT itself serves as the EGC. In this specific scenario, the EMT is running from the 200 amp fusible disconnect to the panel at the new store. Therefore, a separate EGC is not required. NEC Section 250.118 paragraph 10 states that the equipment grounding conductor shall not be required for EMT raceways containing only service entrance conductors. When dealing with electrical installations, understanding the role of the equipment grounding conductor is crucial for safety and compliance with the National Electrical Code, or NEC. The equipment grounding conductor, or EC, provides a low impedance path for fault current to return to the source, which helps to facilitate the operation of overcurrent protective devices such as circuit breakers or fuses. This, in turn, minimizes the risk of electrical shock and equipment damage. In many electrical systems, metallic conduits and raceways are used to house and protect electrical conductors. These metallic pathways can also serve as the equipment grounding conductor, provided they meet certain requirements outlined in the NEC. One common type of metallic raceway is electrical metallic tubing, or EMT, which is a lightweight, rigid steel conduit. EMT is widely used in both exposed and concealed locations for wiring various types of electrical circuits. The NEC recognizes EMT as an acceptable equipment grounding conductor under specific conditions. However, it's essential to understand these conditions to ensure a safe and code-compliant installation. Generally, when EMT is used as a raceway for branch circuits or feeders, a separate equipment grounding conductor must be installed within the EMT. This additional EGC, typically a green insulated wire or a bare copper conductor, provides a dedicated grounding path in case the EMT becomes compromised or disconnected. However, there is an exception to this rule when EMT is used as the raceway for service entrance conductors. Service entrance conductors are the wires that run from the serving utilities equipment to the main service disconnect of a building or structure. These conductors carry the entire electrical load for the building, and their proper grounding is of utmost importance. According to NEC Section 250.118 paragraph 10, equipment grounding conductor is not required for EMT raceways containing only service entrance conductors. In other words, when EMT is used to enclose the service entrance conductors, the EMT itself can serve as the equipment grounding conductor without the need for a separate EGC inside the conduit. This exception is based on the inherent grounding capabilities of EMT, which provides a continuous and reliable metallic pathway back to the source. However, it is important to note that this exception only applies to service entrance conductors. If the EMT also contains other types of conductors, such as branch circuit wires or feeder conductors, a separate EGC is required for those circuits. To ensure that the EMT can effectively serve as the equipment grounding conductor for service entrance conductors, it's crucial to follow proper installation practices. Firstly, all EMT fittings and connectors must be listed for grounding purposes. These fittings are designed to provide a secure and reliable electrical connection between the EMT and the enclosures or equipment it connects to. Secondly, the EMT must be properly installed and supported according to the NEC requirement. This includes using appropriate straps, clamps, and supports to maintain the integrity of the raceway system. Thirdly, all connections between the EMT and enclosures or equipment must be clean and tight to ensure a low impedance grounding path. Any loose or corroded connections can compromise the effectiveness of the EMT as an EGC. In the specific scenario of a 200 amp service where EMT is running from the 200 amp fusible disconnect to the panel at the new store, an EGC is not required within the EMT, provided that the EMT only contains the service entrance conductors. The EMT itself serves as the equipment grounding conductor, offering a safe and code-compliant grounding path. However, it's essential to verify that all EMT fittings and connectors are listed for grounding purposes and that the EMT is properly installed and maintained. It is important to consult the latest edition of the NEC and any applicable local codes or regulations for specific requirements and interpretations related to equipment grounding and EMT installations. Additionally, consulting with a qualified electrical professional is recommended to ensure a safe and code-compliant electrical system. The NEC is a comprehensive set of standards that governs the safe installation of electrical wiring and equipment. It's updated every 3 years to reflect changes in technology and best practices. Understanding the NEC requirements for equipment grounding is essential for anyone involved in electrical work. In addition to the general rules for equipment grounding, the NEC also provides specific requirements for different types of equipment and systems. For example, there are specific grounding requirements for swimming pools, agricultural buildings, and healthcare facilities. These specialized requirements are designed to address the unique electrical hazards associated with these environments. Furthermore, the NEC addresses the use of different types of grounding electrodes such as ground rods, ground plates, and metal water pipes. The selection and installation of grounding electrodes must comply with the NEC requirements to ensure an effective grounding system. Grounding electrodes must be properly sized and installed to provide a low impedance connection to the earth. The NEC also specifies the minimum size and type of grounding electrode conductor, which is the wire that connects the grounding electrode to the electrical system. The grounding electrode conductor must be sized according to the size of the service entrance conductors. In addition to equipment grounding, the NEC also addresses system grounding. System grounding involves connecting one of the current carrying conductors of an electrical system, typically the neutral conductor, to the earth. System grounding helps to stabilize the voltage of the electrical system and provides a path for fault current to return to the source. The NEC specifies different methods for system grounding, depending on the type of electrical system and the voltage level. For example, separately derived systems such as generators and transformers must be grounded according to specific NEC requirements. These requirements ensure that the separately derived system has a reliable ground reference, which is essential for safety and proper operation. Understanding the NEC requirements for both equipment grounding and system grounding is critical for ensuring a safe and reliable electrical system. By following the NEC guidelines, electrical professionals can minimize the risk of electrical shock, equipment damage, and fire hazards. It is also important to stay up to date with the latest edition of the NEC, as changes and revisions are made every 3 years. Attending training courses and seminars on the NEC can help electrical professionals stay informed about the latest requirements and best practices. In summary, when EMT is used as a raceway for service entrance conductors, an equipment grounding conductor is not required within the EMT, provided that the EMT only contains the service entrance conductors and that all EMT fittings and connectors are listed for grounding purposes and that the EMT is properly installed and maintained. Always consult the latest edition of the NEC and any applicable local codes or regulations for specific requirements and interpretations related to equipment grounding and EMT installations. Consulting with a qualified electrical professional is recommended to ensure a safe and code-compliant electrical system. Electrical safety is paramount, and compliance with the NEC is essential for protecting people and property from electrical hazards.